Hi everyone, welcome back to the React interview question and answer series. In this video, we are going to focus on situational React interview questions. These are especially important for senior lead and architecture roles because the interviewer is not only testing whether you know React APIs, they want to understand how you investigate real problems, evaluate trades off, and choose the right solution. For any scenario, we will focus on the problem, the thought process, the practical solution, and the example code. So let's get started. Scenario one. uh, so let's assume React dashboard becomes very slow when displaying 10,000 records. How would you investigate and fix it? So this is how you can answer it. Profile with React DevTools and browser tools. Identify expensive and unnecessary re-renders. Virtualize the list. Render visible rows only. Memorize expensive calculations only when justified. Avoid unstable probe functions that break memory children. Use pagination or server-side filtering. Consider use default value or transitions. So you can see the code example as well in the right side. So for 10,000 rows, use virtualization. Uh, So I would not start by adding use memo everywhere. First, I would profile the interaction using React DevTools Profiler and identify whether the problem is excessive rendering, expensive JavaScript work, or simply rendering too much data. If 10,000 rows are actually mounted in the DOM, virtualization is usually the biggest improvement because only visible rows are rendered. I would also consider pagination or server side filtering so the browser does not receive unnecessary data. In this example, query is the value. The user types deferred query allows the expensive filtered UI to update with lower priority. The use memo calculation filters users only when users or deferred query changes, but this is not a replacement for virtualization when the main bottleneck is rendering thousands of rows. So my senior level answer should be profile first, identify the real bottleneck, apply the smallest targeted optimization, and measure again. So let's move to slide 2. How would you explain the investigation process in a senior level interview? So do not optimize blindly. Measure first, find a expensive component or a interaction, check render frequency and duration, separate rendering, computation, network and data volume problems. Apply a targeted fix and profile again. So this is the mindset I would emphasize in a senior interview. A slow UI can have many causes. So I first measure rather than guessing. I use profiling to identify where time is actually being spent. The flow show here is simple. Start with the slow interaction, profile it, locate the bottleneck, identify the root cause, apply a targeted optimization, and then measure again. For example, if the problem is 10,000 DOM nodes, use memo will not fundamentally solve it. If the problem is a repeated expensive calculation, memoization may help. This important point is choosing the solution based on evidence. So, scenario 2, too many re-renders. A component re-renders every time the user types into an unrelated input. How would you debug this? So the key answer point should be use React DevTools Profiler to find a render cascade. So this is it should be your first statement. Use React DevTools Profiler to find a render cascade. We have to always use React DevTools and it's very helpful. So check whether state is placed too high, move state closer to where it is required, inspect props passed to memoized children, look for a new object, array, and function references. Do not immediately add use memo or use callback. So now you look on the code in the right side. So in this interview you can explain something like so I would profile the render cascade. In this example, search state lives inside dashboard. Every keystroke update search, show the dashboard renders again and React evaluates its children. The key question is whether expensive chart really need to be inside the same state boundary. If the chart does not depend on search, I may move the search state closer to the search feature or restructure the component tree. I would also inspect props because new object or function references can defeat memoization. The important senior level sentences, I would not immediately add use memo or use callback. I would first identify the actual bottleneck. uh, Reference stability. Why can object and function references cause unnecessary renders? Object and functions can get new references on every render. Memorize children, compare props by reference, identical looking values can still be different references. Use memo, use callback can help when stable references are genuinely useful. So now you look on the code in the right side. Uh, so better way to explain it in the interview is like the inline arrow function is created again whenever the parent renders. If the child is memoized, that new function reference can make the prop comparison detect a change. In the second example, use callback can preserve the handle save reference until ID changes. This can be useful when the child's memoized and avoiding a render has measurable value. However, use callback is not automatically better. It adds complexity, so I would only use it when a stable reference solves a demonstrated problem. So next slide, API race condition. So you get a question like a user searches quickly REAC React. So older API responses override newer results. So cancel state request with abort controller or use request IDs with latest response validation. Ignore response that are no longer relevant. Consider 10 stack query for server state. Debounce input when appropriate. So now look on the example in the right side, and this is how you explain it. Explain in a better way in an interview. Each time query changes, this effect creates a new abort controller and start a request using its signal. The important line is the cleanup. Return a function that calls controller abort when the query changes again. React cleans up the previous effect before running the next one so the older request is cancelled. The cache block ignores abort error because cancellation is expected. Other errors are handled normally. The broader issue is that asynchronous request can finish out of order. Abort controller is one solution. Request IDs or validating that a response still belongs to the latest query are other valid approaches. How abort controller bugs? So explain the request lifecycle when the user types quickly. Each query creates a request. The next query triggers cleanup of the previous effect. The previous request is aborted. The newest request is the relevant request. Alternative protection, request IDs, or latest response validation. So, example in the slide, uh, R request A, RE abort A, request B, and so on. So the diagram shows the life cycle clearly. The user types R and the request A starts when the user immediately types RE. The previous effect is cleaned up and the request A is aborted before request B become the current request. The same process continues as the query changes. The goal is to prevent stale asynchronous work from updating the current UI. In a real system, I also consider debouncing to avoid sending a network request for every keystroke. Scenario 4, state management decision. We have auth, theme, dashboard data, temporary model state, and a complex checkout flow. Would you put everything in Redux? So no, classify the state first. Auth and theme may be shared application. State dashboard data is server state. Model state can often stay local or featured scope. Checkout may justify use reducer or a dedicated store. Avoid Redux as a default dumping ground. Look on the example in the slide. Auth is for a shared application state, theme for shared application state, dashboard server state. So my answer would be for this question will be simply no, because these categories have different life cycles and requirements. Authentication and theme can be shared application state because many part of the application may consume them. Dashboard data is server state, so caching, refetching, stale data, and invalidation matter. A server stale tool such as TankStake query may fit better. So temporary model state often does not need to be global. The checkout flow may justify a reducer or dedicated store if there are many related transitions. The architecture should follow the state category instead of forcing every value into a redux. Where should state live? How do you choose the correct state scope? So keep state as close as possible to where it is used. Live state only for a shared source of truth. Use shared state only when the multiple areas need it. Treat server state separately from UI state. Uh, Choose tools based on complexity and assess patterns. So you look in the slide uh, in this example. So in interview, this is how we can explain it. My default principle is to choose the narrowest scope that solves the requirement. If only one component needs the value, keep it local. If multiple components inside one feature needed, move it to the closest common parent or feature level solution. Only use application wide state when the value is genuinely shared. Server state is separate because it comes from an external source and requires fetching, caching, refetching, invalidation. Let's move to next slide. Expensive filtering. An expensive filter makes typing feel slow. What would you do? So the key answer points should be keep urgent input updates responsive, defer expensive UI work when appropriate, use default value for expensive derived UI, consider use transition for non-urgent updates, profile and combine with virtualization if required. So now look on the example in the right side. Here query updates immediately, so the input stays responsive. Deferred query represents a lower priority version of that value. The expensive filter calculation use deferred query. This allows React to prioritize the urgent typing interaction and let the expensive derived result catch up. useMemo avoids recalculating the result when data and default query have not changed. But again, I would profile first. If rendering the results is the main problem, virtualization may be more important. Duplicate server request. Multiple components fetch the same server data. How would you improve it? So do not copy the same server state into local state everywhere. Use caching and request deduplication. Centralize fetching at an appropriate boundary. Use tail time and invalidation policies. consider 10 stack query or an equivalent server stale solution. So look in the code in the right side. Uh, the key idea is to treat server data differently from ordinary component state with a shared query key. A state library can manage caching and allow multiple consumers to work from the same cache result instead of independently fetching the same data. This also gives us a structured place for loading state, error handling, invalidation, and background fetching. Let's move to next slide. Memoize everything. A team wants to wrap every component with React.memo. Is that a good strategy? No, memoization has a cost and adds complexity. Use React.memo for measurable, expensive renders. It helps when props remain stable. New references can reduce its benefits. Uh, in the right side you can see the code. So in interview we can explain like react.memo can be useful but it should not become a default rule. In this example, use row may benefit if the parent renders frequently while the same user object remains unchanged by reference. React can then skip some work for unchanged props. But if the parent creates a new user object, every render memoization may not help. So that is why profiling and understanding prop stability matters. Senior optimization philosophy. How would you summarize your optimization philosophy? So measure before optimizing, fix root causes instead of adding hooks everywhere, reduce unnecessary work before memoizing it, choose the right rendering and data strategy, reprofile to verify the improvement. So example on the slide, profile, understand, optimize, measure again. Show UI, use memo everywhere. So this is the philosophy I would use in a senior or lead interview. First measure, then understand the root cause, reduce unnecessary work before trying to memorize it, choose the correct strategy for the scale of the problem, and finally profile again. The code example is intentionally humorous, but the message is serious. React optimization should be evidence based, not a collection of hooks added everywhere. So, key takeaways. What should a senior lead architect demonstrate in situational React questions? Root cause analysis, profile before optimization, understanding render cascades and state placement, explicit handling of async race condition, correct classification of state, clear explanation of trades off and verification. Senior mindset should be like, what is the bottleneck, why is it happening, what is the simplest correct solution, what are the traits of, how will I verify the improvement. The biggest difference between a mid-level and a senior answer is often the reasoning. Instead of immediately naming an API, start by understanding the problem, explain how you would investigate it, why would you choose a particular solution, what trade-off exists, and how would verify the result. This is the mindset these situational questions are designed to test. So these were some of the most important situational React interviews question for senior lead and architect level roles. The key lesson is to avoid jumping directly to a React API. Start with the problem, investigate the root cause, choose the simplest appropriate solution, explain the trades off, and verify the improvement. This approach will make your answer sound much more practical and senior level. Thank you for watching, and I will see you in the next part of the series.